Hello students. So now let's discuss about the 8051 peripherals, and we will discuss in this about the timers and serial port and interrupts. So after this your 8051 will be completed, and then we will discuss about PIC microcontroller. So let's see about the 8051 timers. So 8051 timers there are two 8051 timers, and this is its working, and it is in the there is a TMOD register. There is a TMOD register where MSB and LSB is over there, and TCON register where MSB and LSB are over there, and there are some control bits which are important for here. So there is a counter and timer. There are two things. One is a counter there and another is timer. Counter works on the external pulses and timer works on the internal pulses. Okay, so next is the gate. Gate is one of the thing which is important, and M1 and M0 decides the modes of the timers. Another controller register is the TCON register, and which has the flags at TF1 and TF0, and there are some other flags also. So when TF1 and TF0 get high, then it means that your timer is overflowed. Okay, so here you can see a diagram where oscillator is there, and oscillator is divided by 12 by internally. So after that this oscillator is connected to the TLX and RX, and here the gate signals are also there. So when the timer or counter signal is connected, C or T is get high at that time, means when C by default it is 0, and it is connected to internal clock pulses. There are two register TLX and THX. X is 0 or 1, or means there are two timers, so TL0 TH0 and TLX TL1 and TH1, and then there is a flag bit TFX which is TF1 and TF0. So when it gets high, when the timer get overflow, then TF bit become high. Okay, so here is the gate signal where I can show you some of the important thing. So here one interrupt also come at that point, and here is the gate signal which we provide. Then it becomes 0 or 1, and at that point we can enable or disable these timers accordingly. Okay, so to apply this timer or counter, we need these four flags. TR1 and TR0 is to start the timer. When TR0 or TR1 get high, at that time the timer starts. When it is 0, then it does not work, then this timer does not work actually. Okay, so TMOD register is there. So there are two gate signal. So when set timer or counter X is enabled, if interrupt X is pin is high and TRX set is set. When cleared, timer or counter is enabled if TRX bit is set. So counter timer, so when set, then counter operation or input from TX input pin. When cleared, timer operation input from internal clocks. M1 and M0 are the mode pins, and these pins has these outputs. So when these are 00, so it is 8048 8-bit timer. TLX serves as 5-bit prescaler. Okay, when it is 01, then 16-bit timer counter are over there, and TLX and THX are cascaded, and there is no any prescaler. 10, then it is 8-bit auto reload timer counter. THX contents loaded into the TLX content when it overflow. 11, TL0 is 8-bit counter controlled by timer 0. Control bits, TH0 is 8-bit timer controlled by timer 1 control bits. Okay, So there so basically this is a split operation. So at 1 1 timer 1 is off, so we cannot use timer 1 in mode 4. So TCON register, so there are some functions of the TCON register bits. TF10 timer 10 count overflow flag set by hardware or timer counter overflow, cleared when CPU vectors to interrupt routine. TR10 timer 10 run control bit set cleared by software to run timer counter on off. IE10 interrupt 10 edge flag set by hardware when external interrupt edge is detected and cleared when interrupt processed. IT10 interrupt 10 flag control bit and set cleared by software to specify falling edge low level triggered external interrupts. So these are the 8051 timers. Timer 0 has all the modes. Timer 1 has only 3 modes. So this is timer 0 working, so which we have already discussed. In mode 0 we have the pre-scaler bits, so maximum count is 1 FFF, so these bits can be used over there. And in mode 2 at mode 1 the full scale of TH0 and TL0 can be used, so the maximum count is FFF. In auto reload timer mode, the TH0 bits are copied into TL0, so this the maximum count is FFH. In mode 3 we have 8-bit timer counter, so these are split timer, and in this we can use TL0 and TH0 separately. So TL0 provide TF0 and TH0 provide TF1 interrupt. And so timer 1, when timer 1 is needed, so TH1 and TL1 we need to follow the TF1, that whether the TF1 is high or not. So mode 0 13-bit, so 5 bits are over there and 8 bits are over there. So when all these 8 bits get high, then at that time this 5-bit get become 1. Okay, so likewise this it works. And if you have any problem regarding a mode 13-bit, I can solve it in the class, in the interaction class. TF1 is the timer flag 1, interrupt is generated after that. So in mode 1 timer 1, both the timers can be used and TF1 is used. In mode 2 similarly, as similar of timer 0, FFH is used. FFH means maximum count is FFH, and here we can use it for that purpose. So for the programming of the timers, indicate which mode and which timer are selected for each of the following: move T mode or #01H, move T mode #20H, and move T mode #12H. Means at T mode 01H we have mode 1 of timer 0 is selected. In this case mode 2 of timer 1 is selected. In this case mode 2 of timer 0 and mode 1 of timer 1 are selected. So we can find the timer clock frequency also, likewise this example. So next is a serial port, and I will discuss it in the next class. Thank you.